Welcome back. In this video, I will show you how Preorder Traversal algorithm works in binary tree. Before starting discussion about the algorithm, I would like to mention the need for this algorithm. Let us consider this binary tree here. Suppose we would like to print the data from the entire binary tree on this screen. Now for that, we need to keep two things in mind. First, each node should be visited only once. And the second, no node should be left unvisited. That means each node should be printed only once without missing any of the nodes here. This is guaranteed by the Preorder Traversal. This is our algorithm for Preorder Traversal. Step 1. Process the node. In our case, it will be the printing the data from each node, right? Second step, move to the left subtree, and the third step, move to the right subtree. Before implementing this iterative algorithm, I would like to show you the rules. This is rule number 1. Suppose you are standing on a node. If you find right child not null, that means there is right child, then push that right child into the stack. If you find right child is null, that means there is no right child, you don't have to do anything, just go to the next step. If you find left child not null, that means there is left child, then proceed down the left edge, and if the left child is null, then pop from the stack. Before starting the algorithm, push null into the stack, increase top, and then push null inside. So, at the 0th index, null is there inside the stack. The purpose of pushing the null here is that during the pop operation, if null comes out, then it will indicate that our traversal is over. For that signal, we are using null here. Now let us start. You set a pointer PTR to the root first. Then you follow these steps. What the step 1 says, process the node, that is printing in our case. So you print A. Your step 1 is over. Next, move to the left subtree. But before moving to the left subtree, you check these rules. Right child? Yes. The C is a right child. So what we should do? Right child is not null, then push that right child into the stack. So we push C into the stack. So increase top and push C. Then, before you move to the left subtree for step 2, you have to check whether there is a left child or not. Now here you see that there is left child. So what you should do? Go for the rule 3. Left child is not null, then proceed down the left edge. So PTR is standing now at this node. Now get back to the step 1 and print B. So every time you visit a new node, you finish the printing job first, then you decide for checking the right child and the left child. So after printing B, we have to move to the left subtree, that is towards D. But before moving, you check whether there is a right child. Yes, there is a right child. What we should do? Right child is not null, so push it into the stack. So increase top and push E into the stack. Then you should move towards the left side. But before moving, you check whether the left child is there or not. Yes, there is a left child, that is D. So perform the third rule, that is proceed down the left edge. So this is a new node. The first job is to print D. Next, you check whether there is a right child or not. Yes, there is a right child. So perform rule number 1. Increase top and push F into the stack. You have to move towards the left, but check whether there is a left child or not. You can clearly see that the left link is null. So follow rule 4. Rule 4 says that if left child is null, that means there is no left child, then pop from stack. So pop F, because F is the topmost element in the stack. Now whatever comes out of the stack, set PTR to that node. So you set PTR to F. Now F is a new node. Print it. Before proceeding towards the left, you have to check whether there is a right child or not. It says no. That means follow rule 2. You don't have to do anything. Check whether there is a left child. It says no. Then go to rule 4. The rule 4 asks you to pop from stack. So, E will come out and decrement top by 1 and set PTR to E. Now PTR is standing on a new node, so print it. Next, you check whether there is a right child. It says no, so you don't have to do anything. Rule 2 says that. You check for the left child. It also says no. Rule 4 asks you to pop. So C will come out. Set top to 0 and set PTR to C. Now this is a new node. Print it. Now you have to move towards the left. But before moving towards the left, you have to check the right child. Yes, there is. So follow rule number 1. Increase top and push I inside. Before moving towards the left, you check whether there is a left child or not. Yes, there is a left child. So follow rule 3. Proceed down towards the left edge. Now PTR is at a new node. Print it. Again, before proceeding towards the left, you check whether there is a right child or not. Yes, there is a right child. Push it into stack. Check there is a left child or not. No, there is no left child. So, rule 4. Pop from stack and set PTR to edge. This is a new node visited by PTR. Print it. Is there a right child? No. Is there a left child? No. Rule 4. Pop from stack and set PTR to I. New node. Print it. Is there a right child? No. Is there a left child? No. Pop from stack. Null comes out. Top goes to -1. Set PTR to null. And your traversal completes. This was our preorder traversal algorithm. In the next video, I will show you how to implement preorder traversal in C. Thanks for watching and take care.